Welcome to the presentation on limits. Let's get started with first an explanation before I do any problems. So let's say I had, let me make sure I have the right color and my pen works. Okay, let's say I had the limit, and I'll explain what a limit is in a second. But the way you write it is, you say, what's the limit? Oh, wait, my color, I'm in the wrong. Okay, I need to use a pen. I'm in yellow. Okay. The limit as x approaches 2 of x squared. Of x squared. Now all this is saying is, what value does this expression x squared approach as x approaches 2? Well, this is pretty easy. If we look at it, let me draw a graph. I'll stay in this yellow color. So let me draw x squared. X squared looks something like, let me use a different color. Let's say x squared looks something like this, right? And when x is equal to 2, y, or the expression, because we don't say what this is equal to, it's just the expression x squared is equal to 4, right? It's like that, right? So a limit is saying as x approaches 2, and as x approaches 2 from both sides, from numbers less than 2 and from numbers right than 2, what does the expression approach? So, and you might, I think, already see where this is going and be wondering why we're even going through the trouble of learning this new concept, because it seems pretty obvious. But as we get to x's closer and closer to 2 from this direction, and as we get to x's closer and closer to this direction, what does this expression equal? Well, it essentially equals 4, right? The expression is equal to 4. The way I think about it is, as you move on the curve closer and closer to the expression's value, what does the expression equal? In this case, it equals 4. So you're probably saying, Sal, this seems like a useless concept because I could have just stuck 2 in there, and I know that, if this is, say this is f of x, that if f of x is equal to x squared, that f of 2 is equal to 4, and that would have been a no-brainer. Well, let me maybe give you one wrinkle on that, and hopefully now you'll start to see what the use of a limit is. Let me say f of x is equal to x squared when if x does not equal 2, and let's say it equals 3 when x equals 2. Interesting. So there's a slight variation on this expression right here. So this is our new f of x. So let me ask you a question. What is, make sure my pen still works. What is the limit? I used cursive this time. What is the limit as as x, that's an x, as x approaches 2 of f of x? That's an x. That says x approaches 2. It's just like that. I don't know. For some reason, my brain isn't working functionally. Okay, so let me graph this now. So, as an equally neat-looking graph as the one I just drew. Let me draw. So now it's almost the same as this curve, except something interesting happens at x equals 2. So it's just like this. It's like an x squared curve, like that. But at x equals 2 and f of x equals 4, we draw a little hole. We draw a hole, right? Because it's not defined at x equals 2. This is x equals 2. This is 2. This is 4. This is the f of x axis, of course. And when x is equal to 2, let's say this is 3. When x is equal to 2, f of x is equal to 3. This is actually right below this. It doesn't look completely right below it, but I think you gotta get the picture. See, this graph is x squared. It's exactly x squared until we get to x equals 2. At x equals 2, we have a graph not a graph. We have a gap in the graph, which maybe could be called a graph. But we have a gap in the graph, and then we keep and then after x equals 2, we keep moving on. And that gap is defined right here. What happens when x equals 2? Well, then f of x is equal to 3. So this graph kind of goes, it's just like x squared and then but instead of f of 2 being 4, f of 2 drops down to 3, but then we keep on going. So going back to the limit problem, what is the limit as x approaches 2 now? Well, let's think about the same thing. We're going to go, this is how I visualize it. I go along the curve. So let me pick a different color. So as x approaches 2 from this side, from the left-hand side or from numbers less than 2, f of x is approaching values approaching 4, right? F of x is approaching 4 as x approaches 2, right? I think you see that. If you just follow along the curve, as you approach f of 2, you get closer and closer to 4. Similarly, as you go from the right-hand side, let me make sure my thing's still working. As you go from the right-hand side, you go along the curve, and f of x is also slowly approaching 4. So as you can see, as we go closer and closer and closer to x equals 2, f of whatever number that is approaches 4, right? So in this case, the limit as x approaches 2 is also equal to 4. Well, this is interesting because in this case, the limit as x approaches 2 of f of x does not equal f of 2. Right, now, normally this would be on this line. This is in this case, the limit as you approach the expression is equal to evaluating the expression at that value. In this case, the limit isn't. So this is, I think now you're starting to see why the limit is a slightly different concept than just evaluating the function at that point. Because you have functions where, for whatever reason, at a certain point, either the function might not be defined or the function kind of jumps up or down. But as you approach that point, you still approach a value different than the function at that point. Now that's my introduction. I think this will give you an intuition for what a limit is. In another presentation, I'll give you the more formal mathematical, the delta epsilon definition of a limit. And actually, in the very next module, I'm now going to do a bunch of problems involving the limit. And I think as you do more and more problems, you'll get more and more of an intuition as to what a limit is. And then as we go into derivatives and integrals, you'll actually understand why people probably even invented limits to begin with. We'll see you in the next presentation.